Earthquakes Resistant Building Design Competition di Universitas Pelita Harapan tahun 2018. 7 besar nasional Lomba Kompetensi Jembatan Indonesia, KJI, kategori Jembatan Baja yang diselenggarakan oleh Kemenristek Dikti di Makassar tahun 2019. Program studi teknik mesin. Program studi ini memiliki fasilitas 7 laboratorium, yaitu Laboratorium Perancangan dan Bedah Produk sebagai tempat uji kompetensi lembaga sertifikasi profesi dengan skema perancangan mekanik umum yang terdapat di ruang teknofis, Laboratorium CNC, Laboratorium Prestasi Mesin, Laboratorium Metalurgi Fisik, Laboratorium Mekatronika, Laboratorium Fenomena Dasar Mesin, Laboratorium Energi Baru Terbarukan Edu Teknopark, menggunakan sistem biodigester dan priolisis, serta sistem pemanfaatan air wudhu untuk menyiram taman dan tanaman kearifan nasional. Program studi teknik mesin, Sekretariat Prodi Teknik Mesin, serta ruang dosen Prodi Teknik Mesin. Inilah beberapa prestasi kemahasiswaan Fakultas Teknik Mesin, antara lain meraih silver medal dan gold medal pada kompetisi Regional Education and Student Product Exhibition Respex periode 2018 hingga 2019 di Port Dickson Politeknik Malaysia. Meraih gold medal pada International Competition Students Creativity on Technology and Culture Ecology 2019 Jakarta, serta meraih juara 2 di ajang Lomba Inovasi Sumber Energi tingkat nasional IEIC Indonesian Energy Innovation Challenge 2019 di Makassar. Program studi teknik informatika. Program studi ini memiliki fasilitas 4 laboratorium, yaitu Laboratorium Network and Security, juga sebagai tempat uji kompetensi Network Designer, Laboratorium Penelitian, Laboratorium Artificial Intelligence dan Komputasi, Laboratorium Software Engineering, dan tempat uji kompetensi Lembaga Sertifikasi Profesi Software Engineer. Prodi Teknik Informatika memiliki ruang sekretariat Prodi Teknik Informatika serta ruang dosen Prodi Teknik Informatika. Inilah beberapa pengabdian kepada masyarakat program studi teknik informatika, antara lain Internet Sehat untuk Ibu Kader Posyandu Budi Harapan Depok tahun 2017. Workshop Sistem Keuangan Desa di Kecamatan Babakan, Kabupaten Cirebon untuk meningkatkan akuntabilitas laporan keuangan desa Juli 2018. Peningkatan pangsa pasar untuk UMKM Batik Cirebon tahun 2018. Edukasi digital marketing Pondok Petir Depok tahun 2020. Pengabdian kepada masyarakat mengenai rainwater harvesting system untuk mendukung pengembangan potensi Pulau Pramuka Juli 2017. Serangkaian beberapa kegiatan mahasiswa Prodi Teknik Informatika mengikuti pameran produk IT dan panitia lomba robot tahun 2018, studi kunjungan ke bisnis startup pada tahun 2018 dan 2019, serta teknik Pancasila bangun desa ke berbagai daerah di Indonesia. Prestasi mahasiswa Prodi Teknik Informatika, finalis tingkat nasional pada Techno Corner 2020 Internet of Things Development Competition di UGM Jogja, Maret 2020. Meraih gold medal dan juara 2 pada International Competition Student Creativity in Technology and Culture Ecology 2019 di Universitas Pancasila pada tahun 2019. Program studi teknik industri. Program studi ini memiliki fasilitas 4 laboratorium, yaitu Laboratorium Statistik dan Optimasi, Laboratorium Manajemen Industri dan Teknik Industri, Laboratorium Sistem Produksi, Laboratorium Perancangan Sistem Kerja, dan Ergonomi. Program studi teknik industri memiliki ruang sekretariat Prodi Teknik Industri serta ruang dosen Prodi Teknik Industri. Prestasi kebahasaan.
Assalamualaikum warahmatullahi wabarakatuh. Shalom, Om Swastiastu, Nama Budaya, Salam Kebajikan. Greetings to Mario Caterino Eng PhD, our speaker for today's session. Morning. This is afternoon here, but yeah, let's say good morning to Mario because in Italy
yes,
still morning.
Good afternoon. Good afternoon.
Good afternoon. But we can get our morning spirit. Like you, because morning is the time where our spirit is in the highest place, I think. Yeah? So we can say good morning also to all the participants that attend this seminar, and welcome to ladies and gentlemen, the attendees of the international webinar and the invited guests. Let all give our praise and gratitude to God for our attendance on international webinar Green Innovation, Green Lean Manufacture. And I am Ilham Syah Akbar from Industrial Engineering Universitas Pancasila, will be the moderator of the opening of this lovely afternoon. In this session, we will listen to the presentation from the speaker. Here is the speaker, Mr. Mario. Hello, Mario.
Hello, Ilham. Thank you for the invitation.
Let me introduce you to our speaker, Mario Caterino. Mario Caterino got his PhD at University of Campania Luigi Vanvitelli. He specialized in operation management field. He got master degree in mechanical engineering from University of Campania Luigi Vanvitelli. He followed the labor or lean robotized assembly and control of composite aerostructure project by Leonardo Company. He collaborated with University of Birmingham on research about optimization algorithm and remanufacturing. Mario has many publications about human-robot interaction and line balancing enhanced by Internet of Things and simulation tools. Oh, that was great. That was maybe one of the newest invention in the engineering, and we will hear so much from Mario. So to conclude this webinar series, I will let Mario to share screen and to share the presentation with us. Okay, Mario, can you share your screen?
Thank you. Yes, sure, Ilham. So just one second, please. Can you see my screen?
Yes, I can see. Yes, I can see my screen.
I think.
Yes. Okay, maybe you can. Yeah.
Yes.
You can get into the full screen mode. Yes.
Yes, I would like. But okay, now you can see the full screen mode, right?
Yes. Okay. Thank you, Mario. Here you go.
Perfect. Thank you, Ilham. Thank you, Ilham, for the presentation. As Ilham said, I am Mario Caterino from the University of Campania Luigi Vanvitelli, and today I will present you this research on the green innovation and in particular on green lean manufacturing. As Ilham right said, I am from the University of Campania, that is in the near to the city of Naples, in the southern part of Italy, in a city that is called Aversa. Our department, I am a part of the industrial division of the Department of Engineering, whose core skills are about aerospace engineering, mechanics, energy and environment, electronics, and especially production engineering. My research group, I belong to the Operations Management Research Group, and we strictly collaborate with the Machine Design Research Group in order to find new solutions for process and product design. Our main topics as group of operations management are about the manufacturing in the era of Industry 4.0, in particular human-centered manufacturing, digital factories, and now we are starting also to work on green manufacturing. As Ilham said, I have worked a lot for Leonardo, so that is an aerospace industry here in Italy, in order to evaluate a human-robot interaction in which we needed to know, for example, the ergonomics of the station with the human and robot. So we worked about digital ergonomies. The group of machine design instead is specialized on product analysis, in particular structural health monitoring, product stress analysis, and crash worthiness. Today we will talk about green manufacturing. That is a topic we are starting to work on. This is the agenda of the presentation. We have to talk about lean and green manufacturing paradigm, but we cannot talk about that without understand the context that are the sustainability and circular economy context. So I will show you some sustainability and circular economy principles. Then we will talk about lean manufacturing paradigm and green manufacturing. I don't think I am able to present also the application case because of the time, but maybe we can talk later in the in our demand and answer session. So let's start with sustainability, the concept of sustainability. In recent years, the world is giving many attention to this word, to this concept. Why? Because sustainability can be defined, as also the World Commission Environment done in 1987, as a development that meets the needs of the present generations without compromising the ability of future generations to meet their own needs. When this concept arose in the early 90s, it was intended as an environmental problem. Sustainability was associated to an environmental problem. But through the years, it was understood that it is not only environmental, but sustainability have to focus on three main pillars: the environment, the economic pillars, and the social pillar. In 1990, for example, Dali suggests the three environmental principles that are: the usage rate of non-renewable resources have to not exceed their regeneration rate, the introduction of pollutants into environment have to not exceed its absorption capacity, and the quantity of non-renewable resources have to be constant in time. On the other side, the economic principle say that the economic growth should always preserve natural and social wealth, while the social sustainability aims at creating an healthy environment in which people may have access to fundamental rights. So it aims to guarantee gender equality, no poverty, no hunger, and so on. Today, unfortunately, we know that not always these principles are respected. For example, you can see in the image on the left that in the last 50 years, the pollutants in the world have increased very much, and there are also some social problems as discrimination, not gender equality, and so on. So the governments, especially here in Europe, I think, are trying to do something. For example, here in Europe, during the program Horizon 2020, a part of the funds go on to the project LIFE, in particular 3.4 billion of euros, which has the 17 goals, which regards quality education, zero hunger, gender equality, detect work and economic growth. All these 17 goals are related to the three pillars of sustainability, so the environmental, the economic, and the social pillars. Let's talk about circular economy now, because circular economy is a way to apply the sustainability concept. In particular, circular economy describes an economic system based on business model that eliminate the concept of end of life of a product through the reduction, reuse, recycling, or remanufacturing, for example, of product, equipment, and so on. It is opposite to the classical linear economy, in which once a product finish its life, is in its end of life, it becomes a waste. So in linear economy, we have the raw material extraction, the production, the use, and then the product become a waste. This is opposite to the concept of circular economy, in which instead, through a design improvement, a life cycle optimization, and by encouraging recycle or remanufacturing, it is possible to eliminate the end of life and so reuse materials or the same product for more time. Why it can be important to apply circular economy principles? Because it has some pros, such as the pressure reduction on the environment. It's obvious if you think if a product is reused or remanufactured, new production can be avoided. So all the energy consumption for the new production and the what we can say the embodied emissions that a new production create can be avoided by means of circular economy principles. Moreover, innovation is another important thing, because to apply circular economy principles, new technologies are needed, and it is estimated that also job can grow, because they will be needed new figures for applying circular economy principles. On the other side, there are some challenges for the application of circular economy, especially about the high costs of new infrastructures, change people habits, and adapt the current job systems. So at this point, we can start about our main topics, that is the lean and green manufacturing. First thing we have to say is that lean and green are often used as synonymous to explain a process in which a process optimization in which the reduction of waste allows to pursue an environmental benefit. But if we go deeply inside the meaning of these two paradigms, it is easy to understand that their objectives are different, because lean manufacturing is centered around the creation of more value for the customer with less work, while green manufacturing main concern is the economic sustainability, and I add also, the ecological sustainability, and I add also the economic sustainability. Obviously, they are related. There are some relation. You can think, for example, to the idle time in production processes, or the waiting time. If you lean manufacturing tries to eliminate the idle time or to reduce the idle time, but if you reduce the idle time, also the energy consumption, for example, for lighting, air conditioning, will be more efficient. So in this case, the lean manufacturing and green manufacturing are related. In other cases, they can be opposite. Think about transportation, for example. Transportation can be done thanks to conveyor belt in an automatic way, or a human worker can transport something, let me say. Which is the difference? The difference is the belt conveyor consume energy, need energy, but it allows to have a greater speed than the human worker, while the human worker does not need energy, electric energy, but it is slower than a belt conveyor. So for lean manufacturing, the belt conveyor is better because it aims at create value. But for green manufacturing, the better solution is the human worker. So as you can see, there are some lean and green manufacturing are related, and sometimes they can be also opposite. Okay, let's start with lean manufacturing. Lean manufacturing concept arose in 1950 when Toyota invented the Toyota production system, which has the main objectives in giving a product with the highest quality at the lowest cost with the minimum lead time. So the concept of lean manufacturing, as we will see, is founded on several tools, on several principles. Two of the most important are the Jidoka and just-in-time principles. Lean manufacturing was born in Japan, so most of the words are Japanese. I apologize if I have a wrong pronunciation. I don't know if there are Japanese in this meeting. I think not. What is Jidoka? Jidoka can be translated simply as automation with human touch. This concept relies on the possibility to immediately stop equipments if a problem arises. But in order to achieve Jidoka, all the systems must be improved in order to become reliable and safe. So first thing, human engineers build the new line component by hand, and then through incremental Kaizen. The Kaizen is a concept that aims at improving the current production system. They simplify the operations on the system built. Why this? Because in the concept of Jidoka, the concept of Jidoka aims also at eliminating the value added by the human operators. What is important here is that each worker that make his job on that station can reach the same results. The just-in-time concept instead is defined by Toyota as making only what is needed when it is needed and in the amount needed. This allows to have a pull system that is a system in which is the customer to call for the production. A production starts only when a customer needs something. This concept is also good to eliminate waste. But a broad overview is needed in this case for having, let me say, the operators need to know the flow of the process, all the tasks, all the operation to be done, and having a broad overview, a smooth workflow is possible, in which, for example, bottlenecks can be immediately identified and eliminated. Through the concept of Kaizen, also here a continuous improvement is needed, and this allows to reach a system in which the small batches are product, and so it becomes a simple and flexible system. About the lean manufacturing, we can identify 5 principles in the scientific literature that allow to apply lean manufacturing, that allow to become a lean manufacturing company. These are the identification of value, the map of the stream, of the value stream, the creation of a flow, establish a pool, and seek perfection. Identify a value means identify an objective, identify a goal that is always defined by the customer's needs. So it is the customer to decide the price point, to decide when he needs his product, and so on. Once the main goal has been defined, the value stream is needed to define all the steps and the processes that have to be involved to have the final product. As said before, to have a map stream, to map the value stream is useful to in order to create also a smooth flow in which bottlenecks can be eliminated. The established pool means that the customer pull the product, as I said before, while maybe the most important thing, but also the most difficult to do, is seek perfection, because this aim to perform continuous improvements thanks to the Kaizen concept, but to have these improvements, also the workers should be involved in this process, trying to suggest a way to improve the production. Lean manufacturing also aims at eliminating wastes, and in particular 7 wastes can be identified, which are maybe some of them also related. One waste is the overproduction. Overproduction arises when the production starts without, but it is not just in time. So if you, according to lean manufacturing principles, if you don't apply the just-in-time principles, an overproduction can arise. Waiting, another waste is waiting, which occurs between two processes when the product is not being processed by any machine or by any worker. An excessive inventory can be dangerous because it needs a lot of cash flow. And so to balance the inventory is one of the most important things. And also here the inventory can be balanced thanks to the just-in-time principles. Motion sometimes can be defined, motion is defined as the movement of people or machines, and in particular for movement of people, it can be a waste when people goes around without a specific objective. This can be caused often by the lack of standardized operations. Transportation is a waste, can be a waste because it is as a waste, does not add value to the product. In fact, excessive transportation may cause damage to the product. Obviously, defective objects are a waste. Overprocessing is a waste. Overprocessing means that we give a product to a customer with the higher specification than he needs. So in order to become a lean company, an existing manufacturing company should implement 25 tools. It's not simple. They may require years and years, but some of these are very important. We have described some of these. Here we add some other, like the 5S principle, which is about the workplace organization method. In this method, the workstation, the station is it is the human worker that manage the workstation. So he has the task of sorting, systemizing, sanitizing, standardizing, and sustaining the workstation. Sorting means that every waste should be eliminated. Systemize means that the remaining items should be placed in the right way. Sanitizing is to maintain clean the workstation. Standardizing means standardize the operations, create a flow of operation in order to do the job in that station in the right way. Sustaining is to apply the standardized operations. Key performance indicators can be useful to track the progression of employees in the company goal and target, as well as the overall equipment effectiveness is an indicator for evaluating the improvements in operation performances. Other important concepts are the Pokayoke or the Plan, Do, Check, Act. The Pokayoke is a simple technique that allow to avoid human errors by checking that each workstation is made in the right way, as it is all okay in the workstation. The Plan, Do, Check, Act is a methodology for improving production. So when an opportunity of improvement arises, this concept can be applied. In the plan phase, the opportunity is evaluated. In the do phase, and the new production way is proposed, and it is checked obviously in the check phase. Results are evaluated in the check phase. If the results are good, the new way for production is acted. It is important also to, as I said, to provide standardized work, standard operating procedures for operation. in order to avoid human errors. And so all these tools have to be implemented in order to make the manufacturing company a lean manufacturing company. Okay, now we can start instead to talk about green manufacturing. That I say there's some connection with lean manufacturing, but its objective is different. Here I reported some definition of green manufacturing. According to the US Department of Commerce, green manufacturing aims at the creation of manufacturing products that use materials and processes that minimize negative environmental impacts, conserve energy and natural resources, are safe for employees, communities, and consumers, and are economically sound. So, as you can see from this definition, green manufacturing concerns the three pillars of sustainability: economic, environmental, and social. Other definitions instead are more focused on the environmental part. In some cases, the term green can also be used as a verb which would refer to the process of reducing the environmental impact of a manufacturing process when compared to previous rate. As I said, there are some differences between lean and green manufacturing, because lean refers to the practice of evaluating if the performed actions by worker are wasteful, and so if they are wasteful, they should be eliminated. While green manufacturing addresses the dilemma of maintaining a progressive worldwide economy without continuing to damage our environment. So, also in the scientific literature, when we use the word green, generally we are referring to two of the three pillars of sustainability that are the economic pillar and the environmental pillar. The social pillar often is not considered because it has some difficult to be considered, as we will notice in few minutes. Which are the advantages of and the barriers of implementing a green manufacturing strategy? First of all, as I said before, today governments are trying to do something to reduce environmental pollutants and to improve also the economic aspect of the companies. So governments are doing some regulations, some new regulations and laws, and obviously companies need to respect these regulations and laws, which are going in the way of the green manufacturing. There are also some economic incentives because the adoption of emission control strategies and pollution prevention strategies allows companies to cut production costs. Moreover, we know that today in the world, the environmental aspect, we are going through climate change and so on. So the environmental aspect is a very important aspect, and many people are starting to focus on this aspect. If a company implement green strategies, also its image is improved for people. On the other hand, some barriers concern the economic, the high costs of new control strategies and waste management process, and of new machine for implement green manufacturing principles. Moreover, there are some technological barriers because some important processes are not supported by technological development. For example, think about the process of for the construction of a car. In this process, the painting phase is responsible for at least the 80% of the total pollutants emission of the entire process. But there is no other way to paint the cars. They need to be used robots and chemical processes that create a lot of pollutants. So the only solution would be to have all the car white, but I think it's not possible. Another barrier is managerial barrier because there is a lack of scientific tools for implementation of green manufacturing strategies. In fact, these tools are needed. These tools are needed in order to improve the production, in order to have some clear metrics about the production process, to measure the metrics of the production process. And the metrics are an important thing to determine a green manufacturing strategy. We need to know if our strategy is good or not, and we can only know this by implementing some metrics. That's not very simple to implement metrics because, especially for the environmental part. Here I reported the metrics for sustainable manufacturing, so also the social part is included. But also, if we want to refer only to economic and environmental part, while economic metrics, there are a lot of economic metrics such as the unit cost or part quality, the net present value, and so on, and I will show you. The environmental and the social metrics especially cannot be related in some time to the part to be manufactured, and this is a problem in order to identify and to define these metrics. But we can say that the general metrics can be divided into three categories that are the financial and economic metrics, metrics for ecology, and metrics for society. In particular, financial and economic metrics are focused on investment decisions and increasing profitability over time. So they allow to understand if the investment in green manufacturing is profitable, and to evaluate if in the future it will be good or not. So I here represent three of these metrics that can be used. That are the net present value, the life cycle costing, and the cost of ownership. In particular, the net present value is useful to the net present value is useful to determine whether an investment in the future cost savings is worthwhile, because it allows to adjust future cash flow into a current time frame, as we can see. In fact, here we have an interest rate I. I0 is the investment in the first period when we decide to implement green manufacturing strategy. XT is the cash flow in the period T. If this value is above zero, the investment is profitable. Then also a life cycle costing is needed. The life cycle costing is needed in order to understand if an equipment or the entire manufacturing system is giving benefits in order of cash to the company. So life cycle costing means evaluate the costs before the use, before implementing green strategies, during the use, and also after the use. The cost of ownership instead is similar to a bottom-up method, and it relies on all the types of cost that should be considered in the implementation of new green strategies. In fact, you can see there is the equipment cost intended as the cost for purchasing facilities, the setup cost, that is the cost for the installation of the facilities, but also the cost of the, for example, of the land, of the machines, and so on. While C3 is the annual sustained cost, it is about electricity, the labor cost, for example. So they are all the costs that have to be sustained annually, yearly by the company. And in fact, as you can see, these costs have to be projected to the present value, because it is a cost that will be also sustained in the future. So it has to be projected in the present, and it is done thanks to interest rate I. At the denominator, we see B, that is the total amount of the output from the system, and VE, that is the economic value of the unit output. Obviously, if COO, the cost of ownership, is smaller than 1, the investment is profitable. Concerning the metrics for ecology, they concern the aspects related to the environment and to a greener production. Here I reported some of these metrics. They all relies on the definition of some criteria. But these criteria can be evaluated in different ways. For example, in the utility analysis, the criteria are weighted, but the weights are subjective, while in the hierarchical approach, criteria are structured according to a hierarchy. The most difficult metrics, as I said, are the ones related to society, the social metrics, because they can be subjective. It is very difficult to evaluate the employee's satisfaction, for example. So in defining the metrics for society, you should have clear which is the objective. We can say that these metrics can be divided into 3 main groups: human development and welfare, equity, and ethical considerations. Some metrics can be referred, for example, in this case, to the wages and benefits for the employees, or also, for example, are related to ergonomic evaluation, or to the hazard related to a workstation. Obviously, if we minimize the ergonomic risk or minimize the hazard of the workstation, the social metric will be high. There is a good benefit for society, for social metrics. Okay, we can see now, we can talk about the enabling technologies of green manufacturing that are not only technologies, but also some strategies. In order to achieve a green manufacturing, a system should be adaptable and reconfigurable. This is general. But this is due to the fact that today the market requires a great degree of customization for products. So adaptability and reconfigurability are very important. Equipment need to be good to adapt to sudden change of production. And for example, in this case, it is suggested that the communities of mobile robots can allow this sudden adaptation, which can also collaborate with humans. Moreover, it's important to decrease the fluctuations during the manufacturing process, and this can be done through models for process optimization under different conditions, or thanks to advanced information technology systems. Moreover, reconfigurability is very important, and also so supporting tools for fast reshaping of production systems should be in a green manufacturing system. Obviously, the green manufacturing aims to be, the green company aims to be an eco-factory in which there is a near to zero emission. How the company can achieve this goal? By implementing, for example, high efficient factory control strategies or new equipment for energy reduction, recovery, and harvesting. Also, simulation can be used in order to analyze the system before it is realized. While the implementation of new key performance indicator of metrics and key performance indicator allows also to capture the multidimensional complexity of eco-factory. This can be defined as strategies, but the real technologies to achieve the near to zero emission factories regards the implementation of smart machines equipped with smart devices that allow to take the production under control. So smart devices as sensors and so on can allow to analyze the machine during their working time. Moreover, technologies for energy efficiency are needed. And in this case, also the ICT technologies can be useful. For example, embedded system microelectronics allows to reduce the energy consumption, while it is important to have systems able of generating knowledge from functional data. So having data from the field, by analyzing that data, we need that there are systems able to generate knowledge, in order, meaning that this system should be able to analyze the data and understand what can happen in that system in the future. This can also be achieved thanks to simulation and digital technologies. Okay, now in order to understand, I will show you some about the remanufacturing process that can be considered one of the pillars of the circular economy and one of the way to apply green strategies. But in order to understand the remanufacturing process, we have to define the life of a product, or in this case, the life of an equipment. We can say that the word life cycle describes the lifetime of an asset, a product, or a component. But it has several meanings depending on the perspective. For example, a customer distinguishes between purchase, operation, support, maintenance, and disposal, while a manufacturer thinks about the product conception, design, the product and process development, the production, and logistics. We can say that each equipment has 5 life stages, life phase. For example, think about today we are through the 4th Industrial Revolution. The technologies of the 4th Industrial Revolution are today in their functional life. That is the period over which the need for the equipment arises, because factories know that they need some technologies. So they start to create these technologies in the functional life. The physical life of an equipment, for example, is the period over which the equipment physically exists. the technological life is the period over which technical innovation makes the equipment obsolete. An example here, I think, can be that today we are at iPhone 12. The iPhone 6 is still working, it is still good, but it is obsolete. So it is difficult to find someone that still uses the iPhone 6. The economic life of the equipment is the period over which the equipment still operates profitably, while the social and legal life is the period until social necessity or legal requirement dictates replacement. For example, here in Italy, we have some cities in which the emissions of the car are limited. So if you want to go to the city center, you need to have a new car. If you have a car of 20 years ago, you cannot go to the city center. And this is an example to make you understand which are the social and which is the social and legal life of the equipment.
Mario, sorry, 10 minutes left. Maybe you can.
Yes, I can finish with this.
Okay.
And
thank you.
So,
okay, continue.
So the problem here also in green manufacturing, as I said, for the circular economy, is to extend the life of equipment or products. How can we extend this life? By means of three strategies that are reuse, recycle, and remanufacturing. In particular, the remanufacturing process is very interesting. Why? Because remanufacturing is the process that returns a product to the same performance specifications as an OEM and applies a warranty at least equal to that of a new product. So we have seen 5 life cycle stages of an equipment. But if we want to simplify, we can say that there are 3 stages: beginning of life, middle of life, and end of life. Now, end of life does not mean that the product is not working, but in some cases it can mean that the product does not fulfill the customer's needs. And in this phase, remanufacturing is a good solution for that program because that product. Sorry, because by means of a process made of several steps, the product is the remanufactured product is restored as new. And this is good also, this is a very good thing if you think to the sustainability concept and especially to the green concept, because you avoid new production of that product, of that equipment. And if you are a customer, you can have that product to a less price than a new one. So it's a very interesting process. In fact, it is estimated also that the remanufacturing market will have a great growth in the future years. Also because governments are trying to are starting to speak about circular economy and sustainability. So it is estimated that, for example, the market in Europe should increase of 300%, arriving at 100 billions of euros. Here in the image on the right, I represented the entire process of remanufacturing. That is not very simple to apply, and it is a problem because there are some issues difficult to solve. Issues about the uncertain timing and quality of returns, the need to balance returns with demands, the fact that there is not disassembly sequence for most of the products. There is uncertainty in materials recovered from returned items and so on. Here, the principal problem is that when a product returns to a company that for remanufacturing, the company is not aware of the quality of that product. So they don't know if which materials can be recovered, how many times will they need for the disassembly process, and this creates, for example, the problem of the highly variable processing times. Today, thanks to some new technologies, some new strategies, some of these issues are trying to be solved. For example, to reduce the uncertainty on the time of returns, market-driven system or closed-loop supply chain can be adopted. Market-driven systems gives incentives to the final customer in order to bring the return if they return the product to the company. In order to reduce also the uncertainty on the quality of returns, the object tracing can be useful because it allows to monitor the object during its lifetime. While simulation and digital twin may be useful to understand the best way for product disassembly, because often the product, when a product is designed by an OEM, an original equipment manufacturer, the disassembly phase is not provided. Is not provided, yes, and so it can be difficult to disassemble a product for remanufacturing industries. The use of robots, for example, can be, when possible, can be useful in order to reduce the processing times. Today, the work in remanufacturing, the job in remanufacturing industries is manual, and so the use of robots can be good in order to reduce the variable processing times. Another technique to implement green strategy is the reuse technique that is different from the remanufacturing. In fact, the reuse allows to, as I said, reuse an equipment without any process. Why can be used? Because especially for assembly equipment, often the manufacturing industries don't use it for the entire physical and technology life that can be also of 20 years, but they only use the equipment for 5, 6, 7 years. So the equipment is dismissed, but it can be reused because often it is still good. And this allows obviously to save costs for new companies that purchase that equipment, as ecological benefits due to the fact that new production are avoided, and allows also to exploit the whole potential of the equipment. On the other hand, there is a lack of standard methods to assess reusability, and so it's possible that an object is classified as reusable, but then when you reuse the object, it is not good, and so it can be a problem. Remanufacturing is still different, as I said, because remanufacturing is applied when the physical and technological life is ended, of the component is ended, in order to extend the life of the equipment. And this extension can be also of 10 or 15 years, considering a technological life of 20 years. So the pros of remanufacturing also here are cost savings and ecological benefits, but also the useful life extension. The problems are the problems I said before, that there is uncertainty on the returned products, and it is a difficult, in some time it can be a very difficult process, especially in some phases. Okay, Ilham, here I should start my application case.
Okay.
Ines, but I think it's not possible because we don't have enough time. Okay. If you want to speak about that, you can ask me and I will show you this application case.
Okay, thank you, Mario. So this is the end of the presentation?
Sorry?
Is this the end of the presentation?
Yeah, I think.
Okay, I think.
I will stop here because I don't have enough time.
Okay, thank you so much, Mario, for your kindness to share your knowledge about remanufacturing and about green lean manufacturing. Okay. I will sum up a little. First, Mario talked about the concept of circular economy and of course about lean manufacturing that derived from the Toyota production system. And he talked about the concept of the reuse and the manufacturing technique and some of the metrics that used to measure the green manufacturing that called green manufacturing metrics that consists of 3 metrics. The first one is financial metrics, the second one is ecology metrics, and the third one, one that kind of difficult to apply it is the society metrics. Okay, Mario, may I start the question and answer session? Okay.
Yes. Can I stop to share the screen, or would you like that?
Maybe you could you could stop share for a moment, and if you need the data, you can open it again. Okay, so to all the participants, maybe you could raise your hand to ask Mario directly, and I have some question in chat room. Maybe some of them will ask you directly, and some of them I will read them from the chat room. Is this okay, Mario? The first one?
Yes.
Okay, if someone wants to ask some question, you can just raise your hand and the host will unmute you. The first question is from Agung. Mr. Mario, is it possible to execute green and lean manufacturing concurrently? Is green manufacturing costly? Yes.
Okay.
The question is in the chat room. You can also read it in the chat room. Okay.
Yes, I read it. Yes, as I said, green manufacturing can be very costly, but I think the world is at the point in which we need to apply green manufacturing strategies. Think, for example, last year, our world, the population in the world finished what the world has given us in the month of July. So in the month of July, all the natural resources created by the world were already finished. So I think today we have great problems: climate change, pollutants, and so on. So green manufacturing is a solution. It is a costly solution because you need to implement new strategies, new technologies, and these technologies have very high costs. But I think it is needed. For the first question, I think, yes, green and lean manufacturing, as I said, they are related, they are connected. They have different aims if we study deeply. But these different objectives can reduce to the same if we think. Lean manufacturing aims to eliminate wastes, but they aims to eliminate waste in order to add value to a product for the customer. Green manufacturing aims at eliminating waste, but to preserve the environment. For example, in some cases they go together. Let me say, if we eliminate some waste, as in the lean manufacturing principles, we can also save energy. For example, and so preserve the environment and give benefits to the environment. So sure, they can be executed concurrently, And even if, as I said in the example of the belt conveyor, in some cases they are also opposite. I hope I answered to the question.
Okay, thank you, Mario. Okay, is there anyone that want to ask Mario directly? Or we have a question in the chat room from
Yes.
Dimas Wisnu Aji from Unsada. Is the Karakuri concept include the solution for implementation lean and green manufacturing? Because Karakuri use the physics method to work. Like Toyota manufacturing, they move the part to next line with elevation method without energy and operator. Also, you can read also in the chat room, Dimas asked about the Karakuri concept.
Sorry, physical concept. I am reading the solution for
yes.
Karakuri use the physical method to work like line in elevation method without energy and operator. Oh, I really I'm not aware of the Karakuri concept. Yes, but as I read in your description, they move the part to the next line with the elevation method without energy and operator. Sorry, Dima, I'm not aware of this method. How is it possible to move something? Let me say, I am born in Fiat factory, and they have some elevators, but they need energy to work. In order to make the car go from one place to another, there are some elevators, but they need energy. I'm not aware of the Karakuri concept, but sure, if you say that it is a method to move the part from one line to another without energy consumption, it is a very good method. So sure, it should be implemented maybe in the green manufacturing, more in the green manufacturing, I think, than in the lean manufacturing, because I think there is a limit for the weight to move from one part to another with the Karakuri concept. So maybe it could be very useful for the implementation of green strategies. I'm not sure about lean, because lean want to add value to the system. This is the aim to transfer something to another part of the line is reached, but I don't know. I think there are some limitations, for example, about the weight that can be transported. I think so. So yes, sure, it can be used for green manufacturing, but I'm not aware for lean if it is a good solution.
Okay, Mario, thank you for your answer. We have a participant that want to ask you directly. So, Mr. Imran Sirait, you can start to ask Mario the question.
Okay, thank you very much for the opportunity. First of all, thank you very much, Mario, for the presentation. I think it's very good. And for the green manufacturer, I think nowadays we know most of the companies are just using just say fossil fuel for energy. So for green manufacturer, the main thing I think it's possible to make to implement, like to use the ecology, eco-friendly, just say energy to run the company. So to make it possible, because to change, to directly change from fossil fuel to eco-friendly fuel energy, I think it takes time or maybe taking cost. So for this one, how is it possible to implement this kind of situation?
Sorry, if I understand, you asked me how it is possible for fuels to implement green system for fuels.
Yep.
Yes, that's a problem. If you think to fuel we here in Europe, we start to say that the fuel of future is electricity. because the carbon emissions due to the cars, machines, and so on are very high. It is very. There are some other fuels, I think, that are more green. I think there exists also some green fuels. But I think in a few years, the fuels that we know today, such as gasoline for cars, and so the diesel engine, for example, in Europe, in some part of the Europe, it is in Denmark, for example, in 5 years, they want to completely eliminate the diesel engines. Because of their emissions. In fact, diesel engines are among the most problematic thing for the pollutants. Even if we have also to say that also electricity it's responsible for greenhouse gases and, for example, and pollutants. But the difference is that cars are in a city, so they are present in the city, so their emissions are where the people lives. While the electricity, for example, I'm thinking to electric cars, electricity is produced not in a city center, but in some part very far from the city center. So in that case, the emissions due to the creation of electricity are not so important as the fuel emissions are. In order to return to your question, I'm not aware about. I'm sure that there are some green fuels, but in the industry of fuel, I think it's difficult to implement green strategies. It's possible to improve some, I think, some production processes. I'm not an expert of fuel production, but I think it's possible to implement some, to improve some production processes. But I think the fuel distribution, the fuel companies will not be totally green, let me say.
Okay, thank you. And Mario, we have two questions from my fellow industrial engineering lecturer. So yeah, two of my comrades, my best friend from work. The first one is from Miss Desinta Rahayu, and the second one is from Mr. Dino. Mr. Dino will ask you directly, but first I will read Desinta question. Desinta said, "Thank you, Mr. Mario. Very interested theme. I want to ask you that mostly that company which apply green manufacturing had an expensive product. So how the company sell their product, because they're pretty much expensive, and how they can convincing the buyer to buy their product, because the cost is pretty much higher than usual."
Yes, it is a very interesting question, because unfortunately I have not enough time to show my application case. But in that application case, we simulated the application, the creation of two spare parts for aircraft industry. So these are two spare parts that have a very high cost. We compared two technologies, the additive manufacturing one and the traditional technologies. So, for example, for numeric control machines and so on. What arises from the simulation is that the cost of the green system, that is the additive manufacturing one, is higher, is very higher than the cost of the traditional system, because for example, in the case of additive manufacturing, the raw materials have a very high cost and so on. But what is important here, I think the right answer is that it is important what you need. If, for example, if governments make a law for which you cannot produce much more by CNN machine, for example, because their emission are too high, you have to adapt and you have to buy new machines with the new green machines. So that's the only way to produce. So also the buyer need to adapt to this, but it is a problem. As you said, right? Because how can I explain? Today, obviously, the economic part is the most important one. It's more important than the environmental. But I think in the future, in 10, 15 years, the environmental part can become more important than the economic. So today is very difficult to try to sell, for example, a spare parts produced in additive manufacturing, because I think we estimated that a flange with an additive manufacturing can cost also more than $100, while its cost with the traditional manufacturing is of $25, $30. So the flange produced with the green solution is 4 times as a cost 4 times higher than the traditional manufacturing. Today, it's difficult to convince a buyer to buy a greenest solution. But I think in the future that it will be maybe mandatory.
Okay, Mario, after Mr. Dino question, I think we have enough time to see your application. Would you still mind to show us after Mr. Dino question?
Yes, if we have time, I'm happy to.
Okay, I'm happy. Okay, it's okay. Maybe one question for Mr. Dino. After that, we can see your application, maybe. Okay, Mr. Dino, you can unmute yourself and you can ask the question.
Okay, thank you, Mr. Ilham, for the opportunity. First of all, I would like to say thank you for your sharing knowledge, Mr. Mario. My name is Dino Rimanto from Industrial Engineering. In your presentation, several challenges related to green manufacturing, such as regulation, economy, competitive advantage were presented. But in my opinion, there are several factors that need to be included in order to comply with the 3 pillars of sustainable development. For example, social factors. This is important in some developing countries because social factors seems difficult to separate it from the 3 pillars in sustainable development. For example, the potential conflict among workers is caused by use of advanced technology such as robot, smart devices, and automation. So how do you think about this social factor, sir? Thank you.
Yes, thank you for the question, Dino. It's another very interesting question. Yes, as I said, I included the social factor in sustainability concept. When I talk about green manufacturing, I am referring to the scientific literature, and generally in the scientific literature, green means economic, environmental. The social aspect is not analyzed, but as you said, it is very important to analyze the social factor. And one of the main concerns in the social factor is the implementation of automation, of robotic, because it is true that when a robot starts to work, maybe a human operator it is not needed, but I think robot can replace human, but can replace human giving benefits to humans. Why? Because I think robots can replace them by making repetitive actions dangerous actions. So those operations in which the human does not add value. Instead, humans, if they are not concerned about the operations, the classical operations of drilling, countersinking, and operations that in which it can be replaced by a robot. In this case, humans can focus their attention in the development and in the improvement of the working systems. So allowing to achieve, for example, better results, to implement new strategies. What I think is that maybe the implementation of robot and automation will give to the human operator a the new tasks that are not the ones of the classical production, in which they make repetitive actions and so on, but a role in which they need to focus their attention on developing strategies for the improvement of the companies. I hope I answered your question.
Okay, thank you, Mr. Mario. Maybe we can conclude the question and answer session. And you can show us, you can share your screen again, Mario, you may?
Yes,
and you can show us your application. Maybe it will open our new knowledge. Good.
I will try to be short. How many time I have, Ilham? Sorry.
It's okay. Maybe you can you finish in 10 minutes?
Yes, I will try.
Okay.
This what so I start. This is important because I tried to we with our group published a research in the Journal of Steel Production on the theme of green selection, of green supply chain for technology selection. In particular, the aim of the research was to propose a quantitative model for the evaluation of different structure of supply chains based on different production technologies that are the additive manufacturing and the traditional manufacturing. So here in the framework, you can see which was the step followed in this research. We analyzed the supply chain structures of the company we want to analyze. We identified some key performance indicators which allowed us to evaluate the importance of the importance of the two strategies within the company. And we applied a multi-criteria decision method that is the analytic hierarchy process in order to evaluate which of these KPI is the most important. Here why this? Because we want to investigate which is the most green solution between the additive manufacturing and the traditional manufacturing. The spare parts here are two parts, a turbine and a flange of, so they are produced for aircraft industry. And the flange has a low demand, has an high demand, while the turbine has a low demand. That is another important thing that can make the difference in the choice of one or another technology. So we analyzed a supply chain system in which there are always three echelons, but they are different because in the conventional manufacturing, we have an original equipment effectiveness that produce the manufacture the product. Then he distributes the product to regional distribution centers, and they sell to the service locations. In the second structure, that is the centralized additive manufacturing structure, there is a raw material supplier which provides the powder to two original equipment manufacturers, and they manufacture the product with the technology of additive manufacturing in this case, and distributes the product to the service level. In this case, so there is only, let me say, 1 or 2 OEM, and so the product is produced by 2 OEM and then distributed to each service level, service location that can be considered as the final customer. In the third solution, instead, the raw material supplier provides the powder to several OEMs. So it is a decentralized solution in which each service location has one additive machine. So the service location becomes the original equipment manufacturer, and they can sell directly to the final customer once the production is ended. So, according to the framework, the first thing to do to understand which is the most effective technology is identify KPIs, the key performance indicators. They depends on the type of the production company and the types of considered technologies. In particular, we identified 10 KPIs in our study. 7 which can be divided into 2 main categories, economic and environmental, and 7 of them belong to the economic category, 3 of them to the environmental. This is related to what I was saying before. To find economic metrics is simple. Let me say it's simple. But in order to find environmental metrics can be more difficult. In fact, we found 7 metrics for economic and only 3 for environment. These metrics regards the on-time delivery, the capacity utilization, the unit product cost, processing waste, holding costs, supply chain lead time, and cash to cash. The environmental metrics are the processing waste, CO2 manufacturing emission, and transport emissions. At this point, we have to sort, to classify the KPIs identified. We have done it by means of an analytic hierarchy method in which 20 experts of the field give us their opinion by means of analytic hierarchy method works by means of pairwise comparisons between the sub-criteria and between the sub-criteria and the criteria. I will not explain which is the analytic hierarchy process, but what is important here is that, as you can see in the image on the right, in the end, all the KPIs were classified, were sorted, and for the experts, the most important KPI, as we were saying before, is the unit product cost. So the cost is the most important thing to consider when you want to choose the application of a new, when you want to evaluate the application of a new technology. So the most important thing is the unit product cost, followed by the holding cost, and the first environmental indicator is in the third place, and it is the manufacturing emissions of the CO2. Yes. Then we applied this study. We developed a simulation in order to understand how the application change for different scenarios. In particular, we analyzed 2 spare parts, as I said, one with the high demand and one with low demand. You can see here P2 and P6. We analyzed for each one of them 12 different scenarios given by 12 different service level. Service level can be defined as the possibility that the out of stock does not verify. So service level 1 is there is a probability that we fix the probability of 65% that the out of stock does not verify, while service level 12 it is a probability of 98% that out of stock does not verify. we need some useful information about the company and the product in order to perform the simulation. Here, for example, you can see the weight of material and the weight of final product, both for traditional and additive manufacturing, the product recycling rate, the cost of raw material, the daily production capacity, and other information useful for the simulation. Here we, for example, represented a particular case study in which all the KPIs, in which are reported all the values of the 10 KPIs are reported with its mean and standard deviation, because we simulated 72 different scenarios, and each scenario was simulated for 25 times. So here you see the results of a particular scenario, with its mean and standard deviation. Then we need to normalize the KPIs. The process of normalization of KPI is a little bit difficult. I think I have not enough time to explain, but it means to make the KPI dimensionless in order to evaluate an economic index I that takes into account all the weights of the KPIs. As you can see in the equation number 3, Wi is the weight of the KPIs that are normalized with the equation number 1. Sorry, while Wj is the weight of the KPIs that are normalized by equation number 2. In this way, it is possible to evaluate 2 indexes, the economic index and the environmental index, as you can see here, for each scenario. And a sustainable final index is then computed to understand which is the best solution. So the sustainable final index say which is the best solution according to our simulation. We evaluated, obviously, the 3 scenarios that are the traditional manufacturing, the centralized additive manufacturing, and the decentralized additive manufacturing, and evaluated the economic index, environmental index, and sustainable index. As you can see, the economic index is the winner. The winner in the economic index is the traditional manufacturing, while for the environmental index, the winner are the additive manufacturing strategies and technologies. But in the evaluation of the final index, in this case, the winner is always the traditional manufacturing, because in the evaluation of the sustainable final index, as you can see in the equation 4, there are the weights of the economic part and of the environmental part. And according to the expert we interviewed, the economic part has an importance of 70%, while can be considered as an importance of 70%, while the environmental part has an importance of only 30%. So if we consider these weights, the sustainable final index say that the traditional manufacturing is still better than the additive manufacturing one, even if the environmental index is very higher for the additive technologies. Here you can see we conducted a sensitivity analysis in which we evaluated for different service level the economic and environmental index. And as you can see, for example, in the environmental perspective, the additive manufacturing technologies are always the winners. This is due to the fact that the emissions, the raw material, the waste connected to additive technologies are near to zero, while the waste related to traditional manufacturing are more than 60% of the raw material, of the initial raw material. On the other side, from the economic perspective, the traditional manufacturing still wins, as you can see, because this is because of what I was saying before. The cost, the unit product cost, is higher for the additive manufacturing. I can make you see here, for example. Sorry, yeah. Here you see, this is the unit product cost for a flange in the traditional manufacturing realization, and this is the unit product cost in the additive manufacturing for centralized solution and decentralized solution. Now, as we said that the unit product cost was the most important KPI, it is easy to understand why, in the economic perspective, the traditional manufacturing is still winner. In the end, we have evaluated the sustainable final index, both for, on the top, there is for the high demand spare part. And for the high demand spare part, you can see that the traditional manufacturing is the best solution, even if the additive manufacturing decentralized is near, we can say here is near, especially for a high service levels. Instead, when we have low demand, so we have a low demand for spare part, the sustainable final index is better for the additive manufacturing centralized than the traditional manufacturing. This is because one of our KPI concerns the rate utilization. And in the case of low demand, the saturation of machine is not very high for traditional manufacturing, while for additive manufacturing it is very high. So due to the low saturation of the machine in traditional manufacturing for low demands, in this case the additive manufacturing centralized solution wins. But we have evaluated all the system, giving weights of 30% for environmental aspect and 70% of economic aspect. But if we change these weights, we tried to do a sensitivity analysis for this. If we change these weights, we can see that when the environmental weight increase, the AM technology become the winner also for the system with the high demand. In the case of low demand, instead, the only winner is the traditional manufacturing only wins when it has when the economic weight is of 90%. But if the economic weight is lower than 90%, the additive manufacturing technology always win. And you can see in particular that the centralized solution is better than centralized solution for high service level, because the holding cost in this case is lower. The centralized solution is lower than the centralized solution. Okay, yes, okay, I finished.
Okay, sorry. Thank you, Mario. It's okay because we are kind of familiar to your method, to AHP method and KPI method, and we I hope in the future we can collaborate and we can enhance our knowledge, because that was so eye-opening, at least for me. Yes,
I would be very happy to collaborate. Yes.
Okay. And anyway, Mario, can you share your email? I think in the last page, you have your email, because some of the participants want to get in contact with you, because
yes, sure.
I think the presentation is very, very interesting topic, and even myself tried. I really want to know more about the metrics.
Thank you very much.
Okay. Before we conclude this event, I will let Mr. Dahmir, Professor Dahmir, to give some closing statement. And meanwhile, to all the participants, you can fill out the webinar presence in the link in the chat room that's shared by Mr. Erlanda Pane. Okay. Okay, Mario, maybe we can let Prof. Dahmir to talk first, and then we can close this event. Okay.
Okay, thank you very much.
Well, ladies and gentlemen, Honorable Dean Engineering Faculty of University Pancasila, Vices of Dean, Department Heads of within Engineering Faculty, all webinar committee, and especially Dr. Mario from Italy. All guests and participants of this webinar, we hereby wish you with our humble greetings. Assalamualaikum warahmatullahi wabarakatuh. May our days in this challenging year full of gratitude, goodness, and happiness as always. We are very happy to report that the 5 seminar series have been successfully carried out. The webinar is held once a week starting 3 of November 2020, except this week we have twice. Today, November 27, 2020, we have also completed all series of webinar with this webinar number 5. The 5 webinar series presented 5 invited speakers from 5 different countries, namely, first, Dr. Stefan Fens from TU Vienna, Austria. Second, Professor Dr. Ing Rafoster from Boyd University of Applied Sciences, Berlin. 3, Professor Dr. Dani Harmanto from the Manford University, Leicester, UK. And 4, Professor Dr. Arno Smet from TU Delft, Netherlands. And last, Dr. Mario Caterino from University of Campania, Italy. In this webinar, various topics based on green innovation have been discussed, including green building, green material, and various techniques for harvesting green energy, the energy storage, as well as lean and green manufacturing method today. We are even more happy to report on several collaborations have been agreed upon as follow-up to this webinar. First, research collaboration and student exchange between Pancasila University and Boyd University of Applied Sciences, Berlin will continue. The second, Prof. Dani Harmanto and one of more his colleagues from the Manford University, Leicester, UK, allows to appointed as a visiting professor at Pancasila University. Third, the research collaboration plan between Pancasila University and TU Delft, which was delayed due to COVID-19. In the field, green energy will be continued by other schemes. Fourth, from Professor Arno Smet from TU Delft allows to be appointed as visiting professor at Pancasila University. Perhaps Dr. Stefan and Dr. Mario also allow to continue more collaboration in the future. We would like to thank to all those who have contributed to the successful implementation of this webinar series. Finally, I officially declare the end and close of this webinar series with the hope that we may meet again in future scientific activities. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Okay, to all the participants, we can take a picture together. You can open your camera and we can do the Salam Pancasila pose. You can raise your right hand. Mario, maybe you can raise your right hand. This is the signature pose of our university. Okay, Erlanda, you can give comment to us.
Okay, please. Okay, 1, 2, 3. Okay, once more. Wait. 1, 2, 3. Okay. Once more again. 1, 2, 3. Okay, finish.
Okay, thank you. See you.
Okay, thank you for the
Thank you, Mario.
attending this
Sukses.
webinar. Big thank you for Mario for sharing knowledge with us. Good luck for your next project and for the future. Maybe we can collaborate a bit more in the future. And thank you for all the committee and the attendance. And officially, I close this webinar. Assalamualaikum warahmatullahi wabarakatuh.
Thank you. Bye, everybody.
Thank you.
Thank you, Mario. Bye.
Okay, Mario.
Bye.
Mario, maybe I will contact you for some for the delivery of the something gift from us.
Yes.
Okay.
Sure. I will wait for you.
And the
Thank
certificate.
you.
Yes.
Thank you, everybody. Thank you, Professor.
Thank you very much.
Thank you very much.